Today we're going to be talking about wastewater and septic treatment. So we've already talked about how you get those resources, and then you're using the water resources, and this is what happens to them after you use them. So when we talk about wastewater, we're talking about these major components: sewage and black water, gray water, and stormwater. And we'll talk about each of those separately. So there's actually fluctuations in wastewater flows during the course of the day. You tend to use the least water between 12 a.m. to 5 a.m., and then that flow rate rises sharply at 6 a.m. Because people start to wake up. Water use in the U.S. is about 45 gallons per person per day on average, and by far the largest domestic use of that water in the U.S. is from flush toilets. So that's where a lot of our wastewater is coming from. As far as those different types of wastewater, gray water is water from your bathroom sinks, showers, tubs, and washing machines that has not come into contact with feces. So it can have other organic material in it like dirt, food, grease, different detergents and things like that, but it doesn't have any fecal matter. Sewage or black water is the opposite. It has come into contact with that fecal matter, and that either came from a toilet or from a diaper. And the feces itself harbors a lot of harmful bacteria and different pathogens, and it also doesn't break down, decompose in water very easily. So that black water can't really be reused, but the gray water can, because it doesn't contain those dangerous things. So a lot of people will put in gray water systems where they basically bring in the fresh water that's been treated to the house that goes in your normal pipes, and then you use that fresh water to wash your laundry, to take a shower, to wash your hands, that kind of thing, and that becomes gray water. And that gray water goes down to a storage tank. It usually gets filtered at least once while it's there, and then that gray water can now be used to water your plants, or become the water that flushes your toilet, or to be used to wash your clothing. So that gray water basically isn't going to harm you if you use it in these ways. And usually these tanks have an overflow built in, so if the gray water tank gets too full, it will just go out to the sewer with the rest of the wastewater. Wastewater also includes stormwater, so that would be all the runoff from the streets, lawns, parking lots, etc. So that would include things like pesticides, fertilizers, lots of different petroleum products from automobiles, other contaminants as well, like heavy metals. This might need to be treated separately, especially if you receive a huge amount of stormwater at once. Then a lot of times this will be diverted. One of the problems with stormwater is that these systems get backed up very easily and flood when it rains a lot. So what that can do is it can actually overflow the sewage lines, and it's actually very, very common, even in this area, even right now, for this to happen and to have raw sewage running through your streams, your rivers, in some cases on your streets. So that's obviously not a good impact. So sometimes they'll treat it separately. This wastewater, when we talk about it, of course, it is mostly water, but it contains lots of other things when you put all these components together. So it has lots of different microorganisms, mostly bacteria. Some of them are good bacteria. Some of them are going to help us with the wastewater treatment, but it also contains pathogenic bacteria like E. coli, Giardia, if you've ever heard of that, Cryptosporidium. These are all bacteria that will make you sick. It contains organic wastes of all different varieties. Lots of these are biodegradable, are going to go away on their own. However, remember that whole eutrophication thing from beginning of the year where we talked about too many nutrients in the waterways are going to cause that algae bloom, and then that's going to create a dead zone. So you don't want to introduce those organic wastes even though they are going to break down. Also, a lot of people now are using things like birth control medication that has hormones in it, and those hormones are passed out when you pee, and a lot of those hormones, if they are left in the water, can act as endocrine disruptors and really make a lot of people and organisms sick. You also have lots of toxic waste components in there, things like cleaners, solvents, pesticides. You have oil-soluble wastes that are going to kind of float on top because they're nonpolar, they're not going to be broken down. And then you have lots of inorganic wastes. Usually those fall into two categories, either salts, which can impact organisms for a number of reasons because water is going to move towards the solute, it's going to disrupt osmosis in their body, and also heavy metals, which are going to bioaccumulate, biomagnify. So when you really think about this and how much goes into your wastewater from a typical house, you can really see that there's a huge number of different things. So you got to think about waste from the toilet, soaps, detergents, cleaning products, food items from a garbage disposal. All of that's going down the drain. So this material's got to be removed so that the water can be safely returned to the environment and hopefully used again by other people downstream. So how they do this actually depends on where you live. But overall, the goal of wastewater treatment is to produce the most pure effluent that is economically feasible so that we can release it back and use it again. So effluent is basically just what we release back into the environment. We want it to be as pure as possible. And you do have to weigh the purity of the effluent with the cost that it's going to take to go through the process. And we've gotten better and better at this as time goes on. This is 1900 to 2000. You can see that we've lowered the amount of effluent contamination quite a bit. But as we learn how to do that, a lot of times our costs will go up, especially when these technologies are new. So it is a balance. There's three basic ways that we treat sewage or wastewater: biological, chemical, and physical or mechanical treatments. So biological treatments are going to involve taking bacteria or plants or some sort of organism and using that to help us with the process. Chemical treatments involve applying certain chemicals and usually removing them afterwards because they're usually used to disinfect, but then they would be poisonous to us as well, so we have to take it back out. And then mechanical or physical treatment is what it sounds like with physical treatment. You're taking things physically out, like you're screening things out, you're putting it through a filter, you're removing particles. Alright, so there's a really important nitrogen cycle connection here, and a lot of people are still reporting they need some help with this nitrogen cycle, so hopefully this helps us kind of connect it. So ammonia is NH3. You make it in your urine, basically. What happens is you have this compound called urea, which is this formula right here, and it's made in your liver, and you pee it out. And once this compound hits the water, it basically dissociates on its own into ammonia, NH3, and carbon dioxide in the water. So it's just going to automatically separate. Now that ammonia can be really toxic to a lot of organisms, so that ammonia has to be taken care of. So we have these bacteria that exist in nature, and these types of bacteria are going to help to break down that ammonia, and they're going to do that through that process of nitrification where they take the ammonia and they turn it into nitrite, and then they turn it into nitrate. And it's actually one of these types of bacteria that do the first step, and then the other does the second step. So that's going to be an important part of some of these processes, is to use those nitrifying bacteria to get rid of the ammonia and make it safe again. So as I said, depending on where you live, your wastewater gets treated differently. So you're either on a septic system or you're on a sewer system. So if you are not on a public sewer, your waste is probably going through a septic system in your yard. And in this case, the waste is going from your home into an underground storage tank. And then it gets separated out into layers. We'll talk about that in a second. It winds up eventually being drained out into, essentially, into your yard and the groundwater underneath it. In a sewer system, it's basically the same process, but on a much larger scale. The wastewater is leaving your house and it's pumped to a wastewater treatment facility, and then it's run through a series of steps to clean the water before they release it back into a creek, river, lake, or ocean. This wastewater system here is going to rely on the force of gravity to move sewage from your house to the wastewater treatment plant. So wastewater treatment plants are usually located on low ground, often near a river, and that's where they're going to drain the treated water. And if the plant is built above ground level, the wastewater has to be pumped up to those aeration tanks that we're going to talk about. So that takes more money to do it. So again, it's going to try to rely on gravity, and then gravity is going to move the water through the process. All right, so let's start with septic tanks. Septic tanks, basically just huge tanks. The water comes in one spot, it settles out into these layers, and then just the watery layer alone is going to go back out into that drain field and into your yard, essentially. There's a couple different important things to point out here. Because it's going out into your septic tank, it kind of, if it was just straight pipes, it would really smell very bad all the time. So you have these P-loops in your pipes, and they hold some water there on purpose. And the reason why they do that is that blocks the gases from flowing up through your sink or up through your toilet or through your tub and your whole house smelling like sewage. And you also have a plumbing vent that allows some of those gases to be released, and it lets the water drain down. You know if something is wrong with this system in your house because you will smell it, guaranteed. Once you're in the septic tank, that water is going to settle into three main layers. The scum layer is anything on top. So it's often going to be those nonpolar oily things. It's going to be the less dense things. The sludge layer is on the bottom. It's anything that's more dense, so it's going to sink. And in the middle, you have this layer that looks like fairly clear water, but it has a lot of things dissolved in it, so it's really not very clean. This is the part that goes back out into that drainage field. So it's kind of been filtered at that point of the actual solids, but it's not really been filtered of a lot of the contaminants that might be in it. So what happens is as the water comes into this tank, it pushes out the liquid that was already in the tank, and you can see the pipe kind of comes down into the middle of that liquid layer, so that it's below the scum, above the sludge. A lot of these tanks have 2 or 3 or 4 chambers, so that this happens over and over, and that can help to filter it a little bit more. And then this water is going out into your drain field, which is also underground, and there's these perforated pipes where that water, that effluent, starts to come out into the soil. And at that point, it would make its way into the groundwater or surface water. And it would return to the hydrologic cycle. So this all depends on types of soils and things you have in your yard. It does have to be drained well, so a lot of times these draining fields will be lined with sands and gravels that are going to drain very well. You don't want them to be lined with clay. All right, so that's septic. Then the wastewater treatment plants that work with the sewers are basically the same process, just much larger scale, and you're going to have more steps. So these tend to purify the water a little bit further than a septic system. And the first step in this is kind of a pre-treatment, or what's called a preliminary treatment. And basically the idea is to get all the big chunks out. So they do something called screening, where they basically just put the waste through a metal screen, and that picks out some of the chunks. They let it sit in a grit chamber where the water starts to slow down, all the grit settles out, and then they can take out the grit from the bottom and remove that and let just the water through at that point. So it's important to remember wastewater that's coming in could even have stuff in it like wood, rocks, dead animals if it's coming from stormwater. So if those don't get removed, they could cause problems later on. So all that stuff gets removed and usually sent to a landfill. Then the first real stage of this treatment system is called primary treatment, or this is usually physical treatment. And basically the idea is to remove those scum and sludge layers. So it does the same thing a septic tank does. It allows the solids to settle out of the water, so you get the sludge layer down here. It allows the scum to rise to the top. You have these rakes that usually circulate around, and they can be more square in shape and go back and forth, or they can be these circular ones that circulate around. And they collect the scum, they thicken it, they pump it along to digesters along with the sludge, and these digesters usually try to break this down even further. They collect that solid waste and they dispose it either in a landfill, an incinerator, a compost, a methane generator, or they could use it for a hydroponic system. And then the primary treatment has, at this point, removed about half of the solids and total organic material and bacteria. So it's gotten it halfway clean, basically. If the plant doesn't do anything else, then the water is chlorinated at this point to kill the remaining bacteria, and then they let it out into whatever stream it is. So some plants will only do primary treatment. However, a lot of them will also do secondary treatment, which is a biological treatment usually. So this is kind of made up of two steps, aeration and settling. So aeration, you're adding air. Settling, you're just letting things sit and settle. So basically, this is to remove the organic materials and nutrients, and they use bacteria to do this, and the water is going to flow to these large aerated tanks where they're pumping in air. The bacteria are able to consume more when they have enough air to do cellular respiration, and then that water gets chlorinated afterwards if this is the last step in the treatment again. This treatment, secondary treatment, is going to remove about 90% of all solids in organic matter. They're also going to kill off these bacteria that they've used, or they're going to pump them out afterwards, so it removes the bacteria as well. But this does not also does, remove the ammonia. So this is where the nitrification step would happen with those bacteria. They would be the ones doing this. All right, and then some systems also include a third stage, although this is fairly rare. So the third stage could be a lot of different things. It could include either filtering it very finely, it's called microfiltration through this very fine filter, or it could include passing it through a series of lagoons or constructed wetlands or an aquaponic system. And the idea there is as it goes through the system, the living organisms, especially the plants, are going to take up a lot of those excess nutrients like nitrogen and phosphorus. And when that's removed from the water, now you're not going to have as much of a risk of eutrophication. So this is pretty cool because we actually have a wetland system like this at school, and it's very rare actually, not only for a school but in general for a treatment plant. So it's a very cool thing to have to look at here. And then another thing it could include is removing those nutrients using chemicals that will coagulate around them and kind of grab them out of the water and settle to the bottom, or using different bacteria that will either perform denitrification or remove phosphorus and things like that. And then the last step, pretty much for any of these different stages, but if you're putting your effluent back into the stream, the last step is always disinfection. So there's three basic ways they can disinfect. They can use UV light. The benefit of that, you're not adding a chemical, you're just irradiating the water. So you're basically killing bacteria because this UV radiation is going to damage their DNA. Or you can add chlorine. Usually you have to take that chlorine out again, or at least a portion of it out so that it's safe to release. Or you can add ozone, and the ozone is actually a highly reactive molecule, that O3 molecule, so it will make it safe to drink. It can also decompose into oxygen. So in any case, the goal is, at this point, this has as much pollutants removed from it as possible. This should be potable water. It should be drinkable. However, tertiary treatment's super, super expensive, so very few communities have actually installed this technology. So as a result, the treated effluent that actually gets released often contains lots of pollutants, and those wind up in our waterways. But that's going to vary community to community, and it's going to depend on how new and how expensive their wastewater treatment was. So these graphics here can just kind of help you to put the process all together and see it from beginning to end. So I'm just going to go through those real quickly, and just pause if you need to and take a look. So again, some treatments are going to only have primary. Sometimes they will have primary and secondary. Sometimes you will have all three, but it is rare. All right, so when we look at sewage treatment, we want to see how effective we were, and that's basically going to depend on how clean our effluent is. So there are a number of different things that they're going to measure about that effluent in order to see if we did our job correctly. So the first one would be pH. So the pH should really match the pH of whatever you're going to put it out into so that you're not affecting the pH balance of any organisms that live there. The next one is called BOD, which is biological oxygen demand. That is basically how much how much oxygen needs to be in the water so that the organisms that naturally live in the water can get rid of all the organic material. So you don't actually want a very high biological oxygen demand because you don't want it to take a lot of oxygen to break down what's left. You want it to be mostly gone already. Because again, if you get into a situation where they're using up all the oxygen to break down these organic materials, that's eutrophication. You're going to get a dead zone where nothing can survive because you're going to use up all the oxygen doing that. So another thing we looked at is dissolved oxygen. We do actually want there to be some oxygen in the water that we're releasing. We don't want it to have a high BOD. We don't want it to require oxygen. We want it to have oxygen in it. So if it has oxygen in it, that way we're going to avoid killing anything and creating that anoxic zone. We don't want to create a zone where there's no oxygen to live in. Then we also look at suspended solids, so that's how many solid particles are remaining in the water. You don't want that to really be high. That's usually one of our lowest, and because that's the easiest thing to remove. Then you also look at phosphorus and nitrogen. These are the main chemicals that are going to cause eutrophication, so you want these to be fairly low. They're usually almost always going to be higher in wastewater than they would in your treated water that's coming in, but you want to keep it as low as possible. You also check the level of chlorine. You have to remove enough chlorine that you're not going to kill any beneficial bacteria. You don't tend to want to have that in your wastewater at all if that's possible. And you want to check your coliform bacteria level. So coliform bacteria are fecal bacteria. So at this point, you should have treated your water to the point that you don't really have any fecal matter left in it. It can make people very sick. That's the E. coli bacteria that you've heard of. And it is important to realize that no matter where you get your water from, you're going to have some coliform bacteria most of the time because it's out in nature. There's lots of wildlife that are pooping, and that's causing that bacteria count to rise, but we certainly don't want to add anything to it. Alright, so next class we're going to come in and we're going to talk about reusing some of that gray water and give you an example, and then we're going to go on a tour of our water treatment plant here on campus. So you need to make sure you dress to be outside or bring a jacket, etc., so that you will be okay. It will be some inside, some outside. And then we're going to take some time to model wastewater treatment as well. So look forward to seeing you then. Have a good night.